Hey friends, in this video I'll talk about geometric progression. So what is geometric progression? So geometric progression is a kind of a sequence with certain pattern as we have seen in arithmetic progression, but the difference is that the geometric progression have certain different kind of pattern. So let's take a sequence. Let's say a1, a2, a3, a4 and so on until an. Let's say this is a sequence, and as we know, we can say this sequence is in AP if a1, if we add a1 with some constant value, let's say d, and we'll get a2. Again we will add certain constant value with a2, let's say again d, same constant value d, and we'll get a3. So as we know that this is an AP. But what's the difference in GP? In GP we need to multiply the constant value. That's the point. Let's say a1 is multiplied with certain constant, let's say r, and we get a2. Now again a2 again is multiplied with certain same constant r, and we'll get a3, and that will go on and on until an. So this type of sequence is known as geometric sequence. Again, that can be finite or infinite depending on the sequence. If the sequence is finite, then the geometric series will also be finite, otherwise it will be infinite. So what we can say right here, we can say that as we know a1 is the first term, so let's say it is a, so it is the first term, just similar as in AP. We will do nothing to the first term and it is only the first term. Now a2 is multiplied by r with a1. So let's say this is a1 is multiplied with r2 if we want to get a2. So that will be a into r. Now a3 we get it by a2 into r, that will be a1 into r. We can write a2 as a1 into r, and again the remaining r over there. Now again a1 will be a, so it will be r into r, a into r into r. Similarly for a4 also, we will write it as a3 into r. A3 will be a2 into r with r, and again a3 a2 will be a1 into 3 r's, right? Now as we can see a pattern over there, what we can write? We can write ar as a r to the power 1, right? Now here we have multiplied r 2 times, so we can write it as a r to the power 2. Again the next one as a r to the power 3. Now we can see certain patterns like here we have a2 and we have just 1 as the power of r. Here we have a3 and the power is 2. Here we have a4 and the power is 3. So we can generalize this thing. So generalizing, what we will get, an is equals to a r to the power what, n minus 1, right? Because as we can see the pattern that is following over here over the sequence, we can see that a2 is a r to the power 1, a3 is a r to the power 2, so an will be a r to the power n minus 1. So this is the nth term of the sequence, nth term of the geometric progression, we can say, or the geometric sequence. So let's go ahead and get example. Now let's say our first term, that is a, is 2, and I forgot to tell you that what is r over here. Why I have taken r? As we know in AP d is taken, and that is the common difference. In here we have r, which is the common ratio, because as we can see we have multiplied it, so it is named as common ratio. So R is, let's write it over here, R is equals to a common ratio. It is known as common ratio. So let's take a sequence first. Let's say 2, 4, 8 and so on. So this is a sequence. How we can find R from the sequence? Simply we will divide 4 by 2, that is we will do 4 by 2, it will get the common ratio. So this will be the common ratio. Again we can do with the third as well and the second term as well, that is R can be found out by third term, that is A3 by A2, that is 4, and we'll get the same thing, that is 2, right? So this is a geometric sequence, geometric progression. Let's take one more example. Now we have to find the sequence. If my first term is let's say maybe 4 and my common ratio will be, let's say, maybe -2. Now what will our sequence, or to be more precise, a geometric sequence? So as we know, the first term is 4, we'll write 4. Now the second term we will get by multiplying the common ratio with the first term, as we knew. Now 4 into -2 will be -8. Now next term we'll get by again multiplying R with the second term, that is -8 into -2, that will be 16. Now again 16 into -2, that will be -32, and so on. So this is my geometric progression or geometric sequence. If my first term is 4 and my common ratio is -2. Now let's go ahead and check this sequence are in geometric progression or not. So my the first sequence we have 5, 25, 125. So in here we have A as 25 and R, let's see R is what. So 25 by 5 is 5, so my R is 5. So we have to check with this one also, that is 125 by 25, it will again 5. So yes, this is in geometric sequence. Now going ahead and let's check with the second one. A is -3 in the second one and R will be -6 by -3, or we can write it as -12 by -6. So in both cases we got 2. So yes, this sequence is also in geometric progression. Now going ahead with the third one, A is half, and let's see with our common ratio, the 3 by 2 whole by 1 by 2, that is 3. In this case, let's say in this case 10 by 2 and 3 by 2, and this is something 3.333. So obviously this sequence is not in geometric progression. So I hope what is geometric progression is quite clear to you all, and if you have any doubt in this particular video, you can comment down below, and thanks for watching.